Good morning and welcome everybody to today's webinar, Integrating Electronics Design into Windchill PLM. My name is Carolina Hägg and I will be your host for today's event. And presenting today will be Perttu Korpela, PLM Business Director and VP of Operations.
Yes, good morning everybody. My name is Perttu Korpela and I work as a PLM Business Director for PDS Vision, and I will be the host of today's webinar where we discuss about how to integrate electronics design with Windchill PLM. And the agenda that we are going to go through with this little bit over half an hour webinar today is to discuss shortly about the role of PLM and ECAD data management system in the flow that we are going to discuss. And we are going to discuss some use cases that are relevant for this, meaning part synchronization, component synchronization between the systems, how to manage central component libraries, how to introduce new parts into the libraries, how ECAD and Mcat collaboration can be improved with a good flow, good systems that are connected, meaning PLM and ECAD data management systems. And finally, we will discuss briefly how to distribute the data that we get from ECAD data management to the rest of the enterprise using Windchill PLM. So the systems mentioned that we are going to discuss are ECAD data management in the middle, the big block there, and then on the left we have the PLM system. Right hand side MCAD, we will just briefly mechanical CAD, 3D CAD, we will just briefly go through a little bit on that, but we mainly will be focusing on these two other systems in today's webinar. And the role of PLM, if we start from Windchill PLM, what that does in general for companies, it captures the full product definition of our product, including different BOM variants of it, manufacturing, service, engineering BOM, and bill of materials. It also manages our enterprise workflows, processes such as change management. It helps us reporting our product compliance, getting the full product definition in one place. And as mentioned earlier, it also does the enterprise data distribution, being a single source of truth for whole company. Whereas the ECAD data management system that is practically being used by the hardware designers and the design team, it has to offer capabilities for component management for the CAD tool being used, help in reusing the CAD data, either projects and existing designs by searching them, again having good control of the templates and components. It manages the actual source data, the data that the CAD system is creating and what is created by the design team. So the layout and schematic files and the output definition files, those have to be managed somewhere, and centrally normally that's done in the data management system used by the team. And it also helps us with the releasing the data, collecting then the manufacturing information from the CAD, putting that together and then pushing that into the PLM system for distribution. Here is the overall swim lane chart that I quite often use when discussing the workflows and capabilities needed in this. Okay, this swim lane is created for Altium Nexus, that is the system that we represent at PDS Vision. But it is a generic one, and the different other CAD systems and data management systems, they have similar functionalities and they need to have similar process support, capability support in place. So the different lanes that we are looking at is the actual data management. As mentioned, the system need to support managing our design files and the template files and the components. It helps us with different processes or workflows, and we will be discussing today briefly one of them being a part request, new part introduction workflow. That is a sample process that we will touch briefly today. And then it will for sure need to support our actual design work. So the most of the work that happens during the design within the team, we are sharing data, we are updating data, and we are exchanging that data with the 3D CAD system that we will also discuss a little bit today. So if we start from the component management and the data synchronization between Windchill and the ECAD system, so what needs to be there in place and is in place is that Windchill offers APIs, REST APIs that can be used by these CAD systems to push and pull data, component data to the Windchill system. So whenever change happens, either in the CAD tool or in the Windchill side, the other system is asynchronously updated in the background using batch job, scheduled batch job. So for a user, it's invisible, or the user doesn't need to worry about the component synchronization. The configuration need to be put in place in a way, of course, that we decide which system is a master for which information. Do we create components in Windchill, or do we create them in the CAD system, or and maybe a field specific ownership need to be defined as well, that Windchill might be a master system for component status information, for example, whereas the CAD system, CAD data management system, is then master for something more technical information that is relevant for design teams. And by having this bidirectional interface, we have always the data synchronized, and it's available for whole company and not only for the engineering team. There are many use cases that need to be supported by such a synchronization. I'm not going to go through those in detail, but just wanted to make a note of that we have thought all those through, that what need to happen wherever when changes happen. So if we are updating information in one side or another, how do we actually go about updating the other system, or when we create data? So all of those different use cases and update scenarios, they have been thought through in detail. And what are the benefits then, what we get from such a data synchronization and having that process in place? As mentioned, we get the visibility to component status. So either it's the hardware design team who knows, for example, end of life status of a component, or if it's a sourcing function that knows it, it can be made visible and accessible for the other teams involved in the designing. We can improve the data quality by enforcing typing and attributes and component templates, design templates, and also, of course, making sure that our PLM Windchill is always up to date, that we have all our components in PLM system, and the data in PLM system, we have one master system managing the whole product information, including then the hardware data. The workflow that we are going to discuss, so I will just show a quick demonstration of managing the components, placing components from a central library, and then requesting new part from a librarian. So that's the flow that we are going to see next. So in this quick demonstration video, we have a design engineer using Altium Designer CAD in this instance. And when we have a central library of components, searching components is very easy and efficient. We have typed our components, and the typing tree or type tree is connected to our Windchill system, so the component classification can be driven by Windchill and then just replicated in the design environment. So then we can search components based on their type, technical values, and we can combine technical values when searching. So then that makes it easy for us to find existing components. And when we have found some components, comparing them, what is the difference between the components, when we know which one to use, just placing it into design is very quick and efficient. And this compared to every user having their own component libraries is of course a huge difference. Now this user is searching for a component by using the manufacturer part number, and we see that okay, this specific component doesn't exist currently in our library, so he will need to submit a part request and having a flow for getting the new component added into the library. So out of the box part request process, new part request process goes something like this. We have an electrical engineer in need of a new component that doesn't exist in our library. He or she submits a request for it. We have a librarian or people who are responsible managing, updating our central library. Of course, depending on the size of the company, it can be one or many persons involved in that. So librarians, they receive the request for a new part, they fetch for the information, they create the part in the library. And in the bigger enterprises, bigger companies, it might then be needed that there is an additional step in between as well, that every component need to be also approved by so-called master librarian or library owner. So he or she then makes it sure that the components that we are adding really are needed, and we have the sourcing information, and we have all the data in place before we add them into our libraries, making the process really kind of helping the users. And once the component has been added to the library, the original requester gets a notification from the system that okay, now your component is in library, and you can use it in your designs. One version of the part request flow, and this is of course always adjusted, modified per customer need and real process that is in place. But one way of looking at adding components into our library. And seeing that as a demonstration video again quickly, so we left there that the design engineer is submitting the part request. So he starts by putting in the information that he knows about the component, the manufacturer, and the manufacturer part number, some date information that by when he would need it. Of course, he would need it most of the time as soon as possible, and he submits the request. So it was not that big of a job for make the request, and he can see from his task list that okay, there is an open request that he has submitted, and what's the status of the request, what's the data that was put into the request form for the librarian to work on. And then we have the librarian who gets the notification from the system that there is a new request that need to be addressed. Okay, he reviews the information that has been put in there, and he starts creating the component then to the library, adding it with the information that he gets. So he uses the typing tree that we saw earlier, and he's also with that manufacturer part number, very easy for him to add the rest of the information into the library. He uses a web search. In this case, it's a system called Octopart that we can very quickly fetch the rest of the information from web service, where we get the technical data. We get also the supplier part numbers. We can see that there are more than one supplier for this component, so kind of safe to maybe add this component into our library. We know that it's an active component. There are more than one suppliers for it. we don't see any problem adding it into our library, and we get the technical information as a template into our library as well, which we can then change. We can add information. We can maybe remove some attributes that are not part of our own data model, remove parameters or add parameters based on our own data model that we use in our company. And of course, we need to maybe edit symbol and footprint information or add some other information to the component that before it can be used by our design team, but just quickly show a simple way of getting this flow in place. May sound kind of a add-on work or additional work, but if you look at it the right way and do it in a simple manner, it's not necessarily adding any overhead to your current way of working. And the benefits of central library management, yes, of course, we all understand that if we have central libraries instead of individual libraries for each designer, we can get better control of components that we are using. We know that they are active components. We are using same numbers, same naming conventions. Quality of the data gets better. We can easily find new components if need to be. If we have central library management today, it's always difficult to know which components are available, and designs need to be maybe adjusted because of the availability of certain components. So again, having a good grip of components makes the design changes easier and easier to predict how and when we are ready with our changes. And design engineer, of course, finds it very quick and easy to add components to the designs that he's working on. Then one of the topics is, of course, the actual design work and managing it. I believe that most of the participants in today's webinar, you are using an ECAD system, an ECAD tool daily basis, so you know what the actual work is when creating the schematics and layouts. And I'm not gonna discuss too much about that side of things, but rather maybe showing you something new that is new information for you, and that's connected to the um, exchanging of data between the electrical CAD system and the mechanical CAD tools. Again, this might be a little bit unique to Altium Designer, but there are different ways of collaborating depending on the CAD system with the 3D CAD tools, the mechanical CAD tools. So the exchange way or the format might vary, but I'm using as an example Altium Designer and co-design functionality that exists there. So when we are talking about Mcat collaboration, what we need to have in place is an efficient, quick way of iteratively exchange data between the two design domains. Our designs are changing both in mechanical side and electrical side, and we need to adjust, and if we can have a good tools and systems, we can be quicker to market with our products, with less errors, with less prototyping, and basically getting our designs ready quicker. And in this Mcat collaboration, what can be exchanged between the tools efficiently, quickly, normally is the PCB board outline, the geometry, shape, and size. Component placement, of course, when we are adding, removing components to our design, that need to be updated in mechanical CAD as well, so that we know that we have space for those and we don't have any collisions and things like that in our product. And then there are holes, mounting holes, through holes normally that need to be placed in our PCB in the right place, and again, not to have collisions with our electrical design and mechanical design. So whenever we make changes, it's best to do it quick and efficient. Again, using a demo video on that so that we can see how this can happen. So we have a PCB designer who has created a first version of PCB design just by placing the biggest components in the design and then pushing that to the mechanical designer to get the collaboration started in the very early stage of the design. And then our mechanical designer is going into cryoparametric, logging into Altium Nexus and that server-based transfer, so not a kind of traditional file-based, which is kind of makes it easy for both. And he pulls the information sent by the electrical designer into his CAD system, cryoparametric in this time. And it's creating a new 3D assembly from the information from Altium Designer in this case. And as you can see, the PCB board is just a flat surface, and then we have the biggest component just placed there, collected there, and now the Mike mechanical engineer need to start modifying the design by creating the right shape for our board. And he's importing first the enclosure where the board need to be fit in. So putting that in place and then modifying the board geometry so that it fits into our this time being used enclosure. Very simple enclosure that we have in this demo, but nevertheless we modify the board. We make the mounting holes in the right places just using standard modeling techniques in Creo, nothing strange there. And then we put the components in the right places where they should go in 3D CAD. We have the big connectors and other components that we are putting in place, and we finalize this version of design in cryoparametric, and we push our changes then back to electrical design so that can be updated on the ECAD side to see what changes we've done in Creo. And then pulling that data back into the ECAD system, we have Paula goes in and she sees that, okay, Mike has made some changes, pulls the changes over. She can review the changes, so preview the changes, what Mike is proposing to her. So the geometry has changed, the component placement has changed. She can accept or reject the changes. Okay, this time she's accepting all of the changes that Mike is proposing, and then she will continue her work to make the design more detailed, of course adding smaller components, making her part of the work, and then pushing it again back to the mechanical side in an iterative way. And when we have such way of working, we can move from file-based, very time-consuming collaboration technologies into more efficient ECAD Mcat collaboration that is based to file server and real version managed way of collaborating and transparent collaboration between the tool, where we can really push and pull data between the tools and be more efficient in our design work. It's good compared to the other ways or some ways that you are most likely familiar with today. If you're using Step DXF or IGES, something like that, or even IDF for exchanging the data, you can see that with the more modern ways of collaborating, you can have functions like review, preview of the changes, accept, reject, and having the whole history of changes logged in the system so that we have the history of changes also kept for our later reference. If we need to go back into an older version, we have an easy way to go there as an example. And finally, we are gonna touch about then what happens when we release the data from ECAD world into PLM. And again, this is a complex scenario in a way that there are a lot of details and different use cases that need to be supported there. But in respect of time, I'm gonna discuss about the end result, what we will get in Windchill when we have the full ECAD data. We have the component synchronizations, design data synchronizations, and everything moved over from ECAD world into Windchill. And what we will get and what we will see in Windchill is the full bill of material of our PCB design. So we have our own internal parts, their technical values, all the information that is synchronized with our design information, the sourcing status, that it's an active component, and if we have more than one manufacturer or vendor for the component, all that information can be collected into PLM in a very easy way, and then that can be used by our sourcing and viewed by our manufacturing partners or our own manufacturing if and when they need that information. So this is a view from Windchill for a bill of material for a board design, an assembly with the board and all the components. And we can see the status information, quantities, reference designators, and all in that bill of material as you would expect. What else than bill of material? As mentioned, we get the actual design files also, so we get the native design files for safekeeping, for master location storage into Windchill over a rich integration such as what I have been discussing with. So we have, of course, ECAD world, but having the native data also in the PLM, again, make sure that PLM is capturing our whole documentation for our product, not just parts of it. Other documents, component data sheets, all of that, they are stored for reference, whoever is in need of those. And then the manufacturing files that are generated by the CAD tool, the pick and place files, Gerber files, PDF files for viewing, and so forth. They are also included as attachments to our board design in the system, and that helps us to distribute the data both internally and externally for our downstream functions, our own manufacturing, our sourcing, and whoever needs that data can be distributed, for example, using my PDS search, our PDS Vision portal system that also supports the ECAD data model in Windchill and can be used to collect and export the data that we have collected into PLM from PCB design. And the benefits or the summary of this release to PLM or check into PLM depends a little bit of what is the terminology, but basically when we release data from ECAD world into Windchill, it's sometimes called as check-in files, but I'm used to using the term releasing to PLM. And by doing that, yes, we of course make sure that our PLM system is capturing the whole product definition, and we can distribute that data, and we know what data is active, what is released, what is prototype, what can be bought in volumes, and what is still under work by design team. As an example, summary of some of the benefits that we get. In my last slide, I have made a quick list of benefits that so of course engineering team, the design team, hardware design team is benefiting having good systems, having good workflows for part introduction, for ECAD Mcat collaboration, all that. Not to neglect that at all. That the engineering and R&D are one of the teams that benefit from having good system support for their work. But many other beneficiaries are, of course, the downstream functions in the company. So we have our product data management, our manufacturing and sourcing. They get quality data from one source that they can rely on. They know what data is released and what is not yet released. Our product compliance reporting can rely on the PLM data. We can make sure that, again, the data is up to date. When we have a good solid system, we can make it easy enough so that the data stays up to date. When changes happen in the design, the PLM system is updated, and then we are on top of our product compliance reporting as one of the examples of the other functions benefiting from putting this kind of a process in place. And with that was my last slide. I a little bit maybe ran over time. Not sure. We still have some minutes left, but I think it's time for questions if there are any, Carolina.
Yes, we have some questions for you now, and great presentation as well. The first question says, I am not sure if PLM is managing all the component information or just the sourcing related data.
All right. Yeah, component information, maybe that is about because there is a CAD specific CAD technical information, and whether Windchill is holding that data in the system or not. Typically not. So the symbols and footprints, those are stored in the CAD tool, either in the data management system as Altium Nexus or Cadence, and those they have their respective system or some central database where we store our symbol and footprint information. But everything else related to component, whether it's data sheets and sourcing data or metadata, technical information, Windchill is aware of that.
Okay, great. And the second question we have is workflows. Do we need to have them in PLM or in Nexus?
All right, yeah, the part introduction, what I showed, that depends on a customer or the configuration. So that if the workflow is such or process is such at the company that it's the design team who is responsible for creating and adding components, they don't need the other functions to participate. Then it's fine just to do it inside the Nexus or EDM system to whole process, keeping it simple within the team. But in some companies, maybe with bigger enterprises with multiple locations and different functions participating into it, or if we rely on change management workflows and such, then the PLM might be master system for that flow. So depends on the I would say the requirement, which system would be the master system for the workflows.
And we'll take one last question. You mentioned that what you presented is not unique to Altium Nexus. Can you reiterate that? Surely there are some differences dependent on CAD tool being used.
Yeah, what we just quickly discussed was pretty generic. Yes, I was using our Altium Nexus slide deck or parts of that slide deck. So the part synchronization between the libraries, yeah, that works pretty much the same with all the systems. Whatever CAD system we are talking, the releasing to PLM is the same use cases need to be there. End result is the same. So maybe one of the unique things in there was the ECAD Mcat demo video that I showed. That is a unique approach that I'm aware of, at least for Altium Designer, and not necessarily doesn't work exactly the same way for other tools. So the data transfer is done by using some intermediate files, normally with other CAD tools that I'm aware of, at least.
Yes. So we don't have any more time for any more questions, but for the rest of you guys who left questions, we will answer them in a personal email to you. And I would like to thank everybody for participating in this webinar. And I hope you've enjoyed this, and this will be available on demand at pdsvision.com, or you can find it on YouTube soon. So thank you, Perto, for this webinar.
Okay, thank you for having me here today.
Thank you.
Thank you. Bye-bye.